Hey everybody, it's Miss Hill and I am back with some scientific notation this week. So we're going to talk a little bit about what scientific notation is in the first place, why do we use it, and then how do I convert back and forth between scientific notation and standard notation. So I've gone ahead and written out a little bit of these notes for you so that I can really talk through them as you record them. So keeping a really awesome math spiral right now would be a fantastic idea, as we will be letting you keep these notes and use these notes when you take module tests. So make sure that you're getting all of these down and check the PDFs at the end of the video to make sure that you've got every piece of the note in your spiral. So what is scientific notation? Scientific notation is a way that scientists have created to note, that's where the word notation comes from, or to write really, really very large numbers and really, really very small numbers. So a lot of our work in science is making comparisons, making observations. So when we have numbers that are written in a similar way or have the same format to them, it's a lot easier to compare the size or the value of those numbers. So when you're having to identify the distance between here and the sun, and a number that gigantic, you need an easy way that you can write that number so that we can compare it to other numbers that are of very different magnitude. So you can see the definition there I wrote, or the reasoning for it, is that we write numbers in SN, I'll use that abbreviation for scientific notation, when they are very small or very large numbers. Here are three pieces of key information that are going to help you really understand what scientific notation is and how we convert. So the first bit of key information is that scientific notation, or SN, uses the power of 10. So everything that we do to these numbers is going to be either multiplying or dividing by the power of 10, or the number 10. The second piece of key information is that every single time I multiply a decimal value by 10, fancy math way of saying if I have a decimal number and I multiply by 10, I move that decimal point 1 to the right. So you can see an example there. I had 4.5, and every single time I every single time I multiply by 10, that decimal point is moving one spot to the right. When I multiply by 10, it moves one more spot to the right. It would go here. Then if I multiply by 10 one more time, I'm going to move it one more point to the right. So multiplying a number by 10 simply moves the decimal one space to the right. Notice that I put a box around the word multiply, and then I put a box around the word right, because I want to connect those two in my mind. The second piece of key information is the opposite of what we just said. So every time I divide, again, I'm going to put a box around that. Every single time I divide by 10, the opposite is going to happen, and I'm actually going to move that decimal point to the left one place. So you can see in the example below that, I started with my decimal point here at the end of my number. Every single time I divide by 10, the opposite happens as in the example above. I'm going to move that decimal point to the left one. Or if I divide by 10 again, my decimal point goes one more to the left. I could keep going. Divide again, decimal point moves back. So you can see when I multiplied 10 3 times, that number got larger. When I divided by 10 3 times, that number got smaller, simply by moving the decimal point. Okay. Under this, let's go ahead and let's make a T-chart. Move my camera just slightly. Let's make a T-chart right under here, and what we're going to call this section is we're going to call this part of the T-chart scientific notation. And then we're going to call the other side of the t-chart standard notation. Get that a little bit better for you. Okay, so what I'm going to do is start with a number that's in scientific notation. Actually, I'm going to write a handful of them and see if you can identify with those scientific observational skills. What are the key pieces to a number that is written in scientific notation? So let me give you this example. One type or one number that's written in scientific notation might look like this. 3.6 times 10 to the 7th. Another example might be 6.7 times 10 to the 5th. Another example might be 1.2 times 10 to the negative 1. Another example might be 2.7999 times 10 to the 3rd. And how about another example might be 4.5 times 10 to the negative 4th. All of those numbers are written in scientific notation. So take a look at those numbers. And the question that I want you to think about is, what is the same about all 5 of those examples? What do they all have in common? I'll give you 30 seconds to take a look at that. While you listen to Pug snoring. Okay, what do they have in common? One thing that they have in common is there is exactly 1 digit to the left of the decimal point. So there's a 3 and then a decimal, 6 and a decimal, 1 and a decimal, 2 and a decimal, 4 and a decimal. So every single number has 1 digit and then it has a decimal point. Now, it doesn't matter how many numbers are after that decimal point. You notice in a lot of them, there's just 1, but here's an example where there's 4 numbers, right? So there has to be at least 1 number to the right of the decimal or after the decimal, but there could be more. And then what else is true? What else is true is that I am always multiplying by 10 to some exponent up top. That's my format for scientific notation. Now that exponent can be positive, meaning it's a bigger, larger number, or that exponent can be negative, meaning I'm creating a smaller number. It's a very, very small distance, for example. Let's look at what I would need to do in order to convert to standard notation. So I am going to use that exponent to boss me around. I'm going to use that exponent to give me my order. So this is a positive 7. Now above, on number 2, we said when you're multiplying a decimal value by 10, the decimal point moves 1 to the right. Now all of these are multiplication, right? But some of them have negatives. So let's see what happens. This is a positive 7. What that positive 7 is telling me is that I am multiplying this 3.6 times 10 7 times. So I'm going to start with my 3.6. And if I'm multiplying that by 10 7 times, what that's telling me is I'm going to move that decimal point 7 times to the right. So I'm going to go 1, 2, 3, 4, 5, 6, 7, and I'm going to place my decimal. Now what do I do with all those loops? I fill those in with zeros. There should be 6 zeros. That would be, without all the loops, I could rewrite that. That number would be my standard notation number. So if I rewrote that, that would be 36 million. Same would be true for the next one. I'm going to start with 6.7. Now, my exponent is a 5. So what that tells me is I have 5 tens that I'm multiplying. That means I move my decimal 5 times to the right. 1, 2, 3, 4, 5. Place my decimal. Fill in with zeros. You're going to notice you always have one less zero than the exponent. Now here's where it gets a little bit wild. I have 1.2, so I can start with 1.2, but look at that exponent. It is a negative 1. Negative is direction, folks, right? Think of a number line. Positive goes right, negative goes left. So I'm still multiplying by 10, but to a negative 1 exponent. That negative gives me my direction. So this decimal goes to the left. And again, I want to put a 0 in front of that just to hold the place value. This would look like 0.12 if I rewrote that. Okay. Let's look at the next example. You started with 2.7999, and my exponent says a positive 3. So I'm going to move this decimal point 3 spaces to the right. 1, 2, 3. So my decimal point lands here. It didn't clear my number. That's okay. That means I landed with, or ended up with, 2799.9. And for our last example, 4.5 times 10 to the negative 4. Again, I'm going to start with 4.5, but my negative 4 is going to tell me to go 4 spaces to the left. Negative is that directional symbol for left. So I'm going to go 1, 2, 3, 4, place my decimal, and fill in my zeros. So again, I really want to put a 0 out there out in front too, so this becomes 0.23 of those zeros, 4, and 5. So my scientific notation is written in this format. Right? Some digit, 1 digit, a decimal point, and then whatever other digits I have left, but only 1 digit to the left. And I'm multiplying it by that power of 10 to some exponent. Standard notation just means that I've gotten rid of the times 10 to whatever exponent. So I've actually done that multiplication or division by moving that decimal point to the right or to the left. I hope this information was helpful. Your teacher is going to share with you another video that's coming directly from EdGems that will review this and add on a little bit more. And then you guys are going to work on a worksheet to get this awesome info into those brains of yours. So hope it was helpful, and I hope you have a really awesome week. Bye.